Welcome to the second episode of the 3AG data series. In our first video, we outlined strategies for a newly minted data leader. Today, we're going to dig a little deeper into the discipline of data engineering. Now, before you reach for that dial, don't worry. We're not putting you through any sort of programming course here. And no, there won't be a test at the end of this video. What we will do is introduce you to the key concepts and considerations in this field. We want you to feel comfortable in knowing why this stuff matters, when to use it, and what to watch out for. Armed with this knowledge, you'll be in a much stronger position to lead your organization through its data journey. So what is data engineering, and why does it matter? Perhaps this is best explained with a metaphor. Imagine that it's 1970 and you've just opened a bookstore. For the grand opening, you stock your store with the 10 most popular books from the New York Times bestseller list. But you soon realize that customers are looking for a variety of books to purchase in addition to the most popular books. So you add books from the top 20, then the top 100. But now customers get confused when they enter the store, because you've gone from stacking books in 10 piles to stacking them in 20 and then 100 different piles. Worse yet, customers start mixing the different piles, which makes it even harder for them to find what they want. So you add a system of bookshelves, putting the books in order of popularity. Customers entering the store can now walk past the most popular books and make their way to the slowest sellers. But then customers start asking you to make special orders. You decide that it makes sense to order a few extra books, since it's a sure sign of demand. See a pattern here? This constant improvement and iteration of the organization of the bookstore's data has strong parallels to the discipline of data engineering. Data engineers are charged with the mission of helping their company to organize its data in such a way as to be not only accessible to the widest audience, but useful for their particular needs. Some employees just need to look at a chart. Others need to do comprehensive analysis. And other employees need to structure the data to allow for advanced use cases such as machine learning and artificial intelligence. Data engineering is the discipline devoted to making all of this possible while simultaneously dealing with an ever-changing landscape, both internally and externally. Why bother? Again, a metaphor will help. Imagine your company as being either a shed, a house, a multifamily complex, or a high-rise tower. The owner of a shed probably doesn't spend much time concerned about engineering permits or maintenance, since this person also doesn't need to worry about maintaining services like heating, running water, or electricity. And if the shed isn't going to be upgraded anytime soon, there's little need to plan for future changes. The owner of a house will need to devote significantly more effort to keep things running when compared with the shed, but even then, they will only need to concern themselves with the needs of themselves and their family. A multifamily complex requires more planning, more resource integration, and a more structured approach to dealing with issues as they arise, particularly since multiple tenants will live in the unit. And a high-rise tower will have a completely different set of engineering requirements, permitting requirements, safety requirements, and so on. Furthermore, a high-rise tower will have a completely different set of engineering requirements, permitting requirements, safety requirements, and so on. The high-rise tower will also be more complicated to manage, particularly if things like fixtures have not been standardized across different units in the building. See a trend here? The more complicated the structure, the greater the need for better infrastructure. More subtle is the fact that earlier planning becomes even more important for bigger buildings, as mistakes and omissions can become costly later on. The same holds true for data engineering within a company. While the smallest companies may not have an immediate need for tools and structures to support data access, companies with aspirations to become bigger will need to consider this issue at some point in their growth. And the longer they wait, the more expensive the effort will be, with more work required to fix past mistakes and omissions. Without a clear data strategy, companies run the risk of carving off small data projects, or worse yet, no projects at all, that don't connect, resulting in a sum that is less than the parts. Forward-thinking companies understand the value of knowing where they are and where they want to go. From a data perspective, this assessment involves understanding where they fit in the analytics maturity model. The majority of companies that have not formally developed a data strategy tend to fall in the descriptive category, performing basic reporting. Those that make a conscious decision to focus on improving their reporting will advance to the diagnostic phase of their journey, where they will not only centralize data to improve the efficiency of their reporting, but also examine the question of why when doing analysis. More advanced stages of maturity include predictive and prescriptive, but in reality, few companies achieve this level of expertise across the entire organization. One common mistake made by many companies is to jump into advanced stage use cases without getting the basics right, or even knowing where they are in terms of analytics maturity. Doing so not only potentially ignores lower-hanging opportunities for improvement, but in the worst case, may set the company up for failure if it chooses to take on a project that ignores earlier stage prerequisites. For example, a company looking to do predictive analysis to support production planning will not be able to efficiently or reliably perform the analysis if all the source data is spread across hundreds of spreadsheets managed by dozens of people. Some definitions. Now that we've explored the high level of data engineering, we'll run through a few definitions. Think of them as bonus points you'll be able to score with your technical team. Data governance. Data governance is where your company gets to set its policies related to how data is collected. It is tightly integrated with data strategy in that the implementation of the rules are defined in the former. A solid data governance policy will not only look to identify which sources to consolidate, but it will define who will be able to access data, when the data is pulled, and what to do when conflicts might occur. The governance policy also defines other issues such as retention policies and how to integrate new sources of data as they come online. A data warehouse is exactly what it sounds like, a structure that organizes and stores your data. Structure has a double meaning here, as structured data, the type you would put in a data warehouse, plays a critical role. Structured data refers to data that is being cleaned up for use. This means ensuring consistent formatting, timestamps, units, etc. Structuring data is more important than you might think. Think about the frustration a user would have in trying to add cells from two different spreadsheets that use different date formats. Now imagine that times 100. A well-designed data warehouse removes this issue. Users know that there is one and only one place where they can access operational and finance data. They know that when they select a particular field, it will be up to date using specific formatting, and that it will play nicely with the other data points. How does the data warehouse achieve this? In the background, it is constantly pulling data from all different sources like ERPs, finance systems, operations systems, and yes, even Excel spreadsheets. Predefined rules from the data governance determine when to pull this data, how to combine it if required, and how to format it. But isn't this just duplication? To a degree, yes. But the benefit of having the single source of truth far outweighs the cost of the data warehouse in terms of ease of access, having a clean set of structured data, and overall sanity for your analysts. A data lake is basically the same thing as a data warehouse, but unstructured. On the one hand, it's good for having a central store of all data, but on the other hand, it's like throwing everything into a closet or a basement. Eventually, the clutter overwhelms you, and chances are that you're not going to use the things that are at the bottom of the pile. Data lakes are great for exploratory and unstructured analysis done by a dedicated data analyst or data science team that knows their way around. However, as the name implies, if you don't know how to swim in the lake, you may drown in it. Plus, if you don't manage the data going into it, you'll end up with a data swamp. Nobody likes swimming in a swamp. Better to use a data warehouse instead. Don't worry. This isn't a programming class, and you don't really need to know this alphabet soup of terms. Personally, I don't know what a carburetor does or why you need a Buell injector, but my car still runs fine. Hopefully you found this video helpful. We reviewed key concepts associated with the discipline of data engineering. By now, you should understand why you need to consider data governance, data strategy, and ideally implement a data warehouse. We look forward to seeing you in the next video.